Welcome to the Podkey Summary of SwiftUI for Beginners Group Lab from WWDC 2026. This week's SwiftUI conversation really comes down to three things. Why Apple keeps making the case for native UI, how to use SwiftUI without blowing up an existing app, and how the tools around it are getting a lot more practical. There's also a useful thread running through all of it, which is that SwiftUI works best when you treat it like its own system, instead of trying to force old habits into it, whether that's state management, layout, or even AI code help. Apple engineers are making a pretty direct argument against the cross-platform pitch, especially the React Native kind of pitch, where code reuse sounds amazing on day one. Their point is that when Apple ships a new visual language or behavior, like Liquid Glass, SwiftUI gets there immediately because it's wired right into the platform. Cross-platform frameworks can absolutely get you a shared foundation, but the complaint is that the hard part often shows up late when you're chasing polish, platform quirks, and all the little iOS-specific details users notice, even if they can't name them. So for an iOS-only product, the argument is less about ideology and more about total effort. You may save time up front with shared code, then spend that time back with interest when the app needs to feel truly native. One of the more reassuring points here is that SwiftUI was built for incremental adoption. You do not have to light your UI kit codebase on fire and start over. Teams can migrate only the screens or components that actually benefit from SwiftUI's declarative approach. That works partly because SwiftUI views are structs, so they're easy to compose, wrap, and swap in piece by piece. It lowers the risk and makes the learning curve a lot less scary for established teams. If you're new to SwiftUI, one of the biggest mindset shifts is understanding why @state exists at all. A SwiftUI view can be recreated over and over, so if you try to keep mutable UI data in a plain struct property, that data would just get tossed out during reconstruction. What @state does is create a hidden storage slot that SwiftUI owns, so the mutable value survives even while the view itself is being rebuilt. That's also why the compiler pushes back when you try to mutate plain stored properties in a view. It's not being fussy for sport. It's trying to stop you from putting state somewhere that won't behave reliably. Performance gets more interesting when state changes all the time, like with sensors, timers, or anything updating every frame. The recommendation there is to use patterns like @observable_object, along with tools such as lazy stacks or timeline view, so only the views actually reading the changing data get redrawn. And then there's the less glamorous but very real advice. Break giant view bodies into smaller reusable views, and don't create expensive things inside body if you can help it. Number donors is the classic example. If you build one every redraw, your app may start sounding fine in theory and feeling weird in practice. On the tooling side, Xcode 27 adds SwiftUI-specific skills for its built-in coding agent. And that matters because generic code generation is often where newer Apple APIs get mangled. These skills are automatically active when you're editing a SwiftUI file, and they feed the model current API knowledge, best practice patterns, and warnings around common mistakes, like missing @state or misusing environment values. If you use an external LLM instead, you have to import that SwiftUI skill set yourself. Otherwise, you're basically asking for advice from someone who skimmed last year's notes. The smartest guidance I heard was to treat the model like a tutor, not a ghost employee. Ask why it chose something. Ask for alternatives. Use it for reviews. And don't just accept whole file output because it arrived confidently. For people starting from scratch, the suggested path is refreshingly grounded. Start with Swift fundamentals first, then move into simple SwiftUI apps through Apple's interactive tutorials. And after that, work through something like Paul Hudson's 100 Days of SwiftUI for regular bite-sized practice. The key advice is to tie all of that to a personal project. Build something that solves a real annoyance for you or for a friend, because motivation gets a lot stronger when the app has a job besides being lesson number 7. If you come from HTML and CSS, SwiftUI tends to feel more familiar than people expect. The declarative hierarchy maps pretty naturally to the way web developers think about DOM trees and nested layout structure. And Xcode previews help a lot, because they offer that live update feeling that web people are used to from hot reload. It softens the jump from browser iteration to app development. Another theme from WWDC was layout flexibility across iPhone, iPad, and Mac. SwiftUI is getting stronger adaptive layout primitives and custom layout APIs, which matters because modern Apple apps are expected to stretch and reshape gracefully instead of pretending every user owns the exact same rectangle. That's where Device Hub comes in. It's a preview tool in Xcode that lets developers test across a broad mix of aspect ratios and device classes, which is a good antidote to the very human habit of perfecting one screen and calling it a day. On the design handoff side, Apple's ecosystem now includes Figma and Sketch connectors that can generate SwiftUI code from design files. That can speed things up, but when the automatic conversion falls short, the advice is to manually map components to the right SwiftUI layout primitives, whether that's a VStack, a lazy V grid, or something more custom, so the result stays responsive instead of merely looking correct in one screenshot. The big takeaway is that SwiftUI is maturing in a very practical way. Better native integration, easier adoption, sharper AI support, and stronger multi-device layout tools all point in the same direction. And maybe the nicest part is that the advice here isn't mystical. Learn the fundamentals, keep state where SwiftUI expects it, test on more than one screen, and make the tools explain themselves. This episode was generated by Podkey. Create your own at podkey.fm.